welcome to an algebra tutorial video. We are learning about linear modeling and going to be tackling some word problems and actually applying everything we know about linear equations. So when we say linear modeling, all we're doing is taking our algebra, our linear equations, different forms, slope, all these great concepts, and then trying to apply it to situations, patterns, contexts around us. We're modeling what we see with a linear equation. Okay, so here's a problem, a common type of problem with linear modeling. In 1978, the US minimum wage was $2.65. In the year 2009, the US minimum wage had increased to $7.25. Use a linear equation to model the increase and estimate the US minimum wage in the year 2020. Okay, there's a lot going on here. We got some data, we got some numbers. These are pulled straight from a US government website. Let's talk about how to model these with a linear equation. So thinking back on everything we've learned in your algebra class with linear equations, we need to have a couple points to be able to find the slope. And then once I have a point and a slope, that's enough to write a point-slope form equation to model some sort of situation. So a lot of times, the first thing you want to do is try and find out, well, okay, what am I being told and how can I convert that into a couple of points? So let's see what we got here. We know that in 1978, the minimum wage was $2.65. We then know that in 2009, the minimum wage had increased to $7.25. Hopefully writing it out this way makes it look a little bit more obvious. We have our 2 points right here. We have our independent and dependent variables, and we can see, oh, as x is changing, we're going to make this my independent variable. So x is just going to represent the year. And my y, as years are changing, how does the minimum wage respond to the changing years? It's increasing. So y represents the US minimum wage. All right, so we've interpreted our problem. We've got a couple points. I could plot these points on a graph if I wanted to. And importantly, we've defined our variables. There is actually something I'm trying to pay attention here. So we can't just be abstract, but we need to give meaning to all of our numbers. We need to give meaning to all of our variables. And it helps a lot to make sure we're keeping that meaning straight throughout the entire problem. So whenever we refer to x, x is just the changing year, and y is the US minimum wage in response to that year. Okay, so now we got 2 points. Once we have 2 points, we can find the slope of a line. So let's go on here. Let's find the slope of the line. So the slope of a line between any 2 points is how much change happened in my y values divided by how much change happened in my x values. Well, let's see what we got here. So we know my 2 y values. I went from $7.25, subtract $2.65. I'm going to find that change in all my y values. And then I'm going to find the change in my x values, 2009 minus 1978. All right, let's pull out a calculator and do some quick math here. $7.25 minus $2.65 looked like an increase of $4.60. Okay. While that was changing, how many years did we have an increase of? So 2009 minus 1978, that's going to be a change of, let's see, 31 years. So over a 31-year period, I'm going to include my units. So this makes it obvious, we got a ratio here. Over 31 years, we had an increase in the minimum wage of $4.60. Well, we usually divide them at this point, right? Slope is just an average rate of change, so I want to divide that $4.60 by 31 years. and we see that we get kind of an ugly decimal, but 0.14, and I'm going to round it to 8, to the nearest third place. And what we see is that it's an increase of about almost 15 cents, a little under 15 cents per year. So our slope has some meaning. There is an average rate of change. Every year we're increasing on average by almost 15 cents. Now if you really look back historically, it stays flat for a few years and there's a big jump next time they vote on increasing the minimum wage. Then it's flat for a few years, then there's a big jump. So it's not the exact change, but it's an average rate of change. It's kind of saying, well, on average then over this 31-year period, here's how much it changed if you want to get a nice slope or a nice linear equation. All right, so we've got the slope. We still want to use a linear equation to model it. So now we're going to get into, let's use one of our points. Let's use our slope, and we're going to write a point slope form equation. So point slope form, remember, it's the easiest one to write an equation. It's just y minus y1 equals m times x minus x1. So we use one of our points, x1, y1, and we use our slope, and we can put it together in an equation. All right, so we've got, I'm going to use this first point, the 1978 265 point. So to get an equation, we have y minus our specific y1 value, $2.65, equals our slope. We're going to use 0.148 times x minus x1. For $2.65, we had an x value of 1978. So it's sort of like saying when we use these points, it's saying, well, my y value is already $2.65, so that's going to adjust future y values. And we're already fixing it around 1978, so x has to be more than 1978. We're already kind of fixing it beyond that point. So we've got it fixed around a point. We're using our slope. We actually have an equation we can use now. So we've got a linear equation. I'm checking that off. Now we need to use the linear equation to model the increase and estimate the US minimum wage in the year 2020. So I can graph that. I could use a graphing calculator, a graphing program, put that in. I can get a nice graph and use it to approximate values. But the year 2020, I've already defined x as the year. So this is just a particular x value. And I can put that into my equation and solve for y. So that's what I'm going to do. I'm actually got an equation. I'm going to use my equation. Let's line this off here. And I'm going to put 2020 in for x and solve for what, according to my equation, should be the minimum wage in the year 2020. All right, so we've got y minus $2.65 is equal to 0.148 times, I'm going to know, well, what about the year 2020? So we're putting that in for my x value, and now we're going to solve it out. This is the great thing about once you get to an equation, you can find all sorts of good values. All right, so let's solve this thing. If I calculate all this on the right, 2020 minus 1978 is equal to 42. So we've got 0.148 times 42 is equal to y minus 2.65. 42 times 0.148 is simplifying to 6.216. And lastly, to solve for y, let's add 2.65 to both sides. So we get to, that turns to 0 plus 2.65. Approximately, I'm going to round it to the nearest penny because we want to approximate the value of the dollar. So we get 8.87. So according to my model, which we based off these 2 points and formed, we found the slope, the average rate of change, wrote a point slope form equation, and we used our equation to estimate in the year 2020, it seems to come out that we should get a minimum wage of $8.87. Now, already there's conversation about putting it at $9. So we've seen kind of more, maybe a linear equation with these 2 points isn't the best sort of trend. But this gives you an idea about how mathematicians work, how statisticians work, how we can actually use math to try and model and understand things that we see going on around us. So we tried to use a linear equation, and we're able to get an approximate model to see, well, what will be the future US minimum wage. All right, hopefully that was a helpful linear modeling word problem for you guys as you're understanding how we use concepts such as slope and linear equations.